Good afternoon, my dear students. Today we are going to start the topic maxima and minima. It is a part of that is called application of derivative. Most important topic of application of derivative, where a 6 marks questions always asked from in the final examinations. So this chapter is related to our previous chapter, increasing and decreasing function. So using this increasing and decreasing functions, what we will do, we are applying the concept of increasing and decreasing function. We will understand the concept of maxima and minima. So let us start with the topic. See, here I am drawing a function y is equal to what? Graph of the function y equal to what? Fx, and which is defined on an interval what? Defined on an interval what? I, and where c belongs to c is a point in I. And value of the function y equal to fx at the point c is given by what? Fc. Okay, and you see all the point left of c are less than c. All the point left of c are less than c, and for every x there is a value of what? Fx. For every x there is a value of what? Fx. And you see every fx, when x is less than c, every fx is less than what? Fc. Less than what? Fc. Also you see in the right of c there are many x within this interval, and these are greater than what? C. Greater than what? C. And for every x there is an fx. There is an what? Fx. There is an fx. And you see all the fx are also less than what? Fc. That means what happened? We get the condition fx is less than what? Fc for all x belongs to the interval I. For every x in the interval I, whatever with the fx we are getting, all fx are less than that particular fc. Fc is a particular value of the function at x is equal to what? C. So from this condition we can say that fc is what? Is the maximum value of fx at x equal to what? C. Okay. So since fx is less than, all fx are less than fc, means what? This fc is a particular value which is greater than all fx in the graph of the function. With whatever with the x in the domain, for every x you are getting fx. Okay. For all fx, fc is what? Fc is what? Greater than fx, or you can say fx is less than fc. So from here you can conclude that fc is the maximum value of fx at x equal to c. And this point c, x is equal to c, is called the point of maxima. Point of maxima, or you can say maximum. Point of what? Maximum. This x is equal to c is a point of maximum, and fc is called the maximum value of fx at x equal to c. This is the basic definition of that when a function have a maximum value in a particular point in a domain, or here domain is defined as interval I. It is an open interval. Okay. Now how we can introduce calculus here? That is the most important things. So from the basic definition we understand that at the point c, fc is the maximum value when all the fx is what? Less than fc for every x in the I. Now here I am going to see if that particular point you see, you draw a tangent. The tangent is parallel to x-axis. That means at the point x equal to c, what happened? F dash x equal to 0. F dash x equal to 0. That means you can say f dash c equal to what? 0. And if you consider the points on the card, in every point you can get a tangent. This is a tangent. You can draw a tangent here, or you can draw a tangent here. So you see all the tangents are making angle what? This type of angle. Making angle this type of angles. All the angles are what? Less than what? 90 degree. Here theta is less than what? 90 degree. Theta is less than what? 90 degree, okay? And since theta is less than 90 degrees, so theta is acute angle. Theta is acute angle, and when theta is acute, you know that tan theta is positive quantity. Tan theta is what? Greater than 0. But according to calculus, what is the slope of the tangent? F dash x. This tan theta represents the slope of the line, and since the lines are tangent, therefore you can say that slope of this line will be denoted by what? F dash x, because these are tangents. So f dash x is equal to tan theta, and tan theta is greater than 0. That means what happens? Whatever be the x left of C, when x approaches to C from left to right, okay, x is approaches to C from left, not right, from left, then what happen? Whatever be the f dash x you are getting, all f dash x are what? Positive. All f dash x are what? Positive. And exactly when x reaches to the point C, f dash x equal to what? 0. And when it crosses C and move toward this right, what happen? You will get points, and every point you are getting a tangent. Every point you are getting a tangent. And you see what happen? Tangents are making angles what? Tangents are what? Making angles. These are the angles. And this type of angles are what? Greater than 90 degree, and these are called obtuse angle. And for obtuse angle, we know that tan theta is what? Less than 0. And tan theta means f dash x. Tan theta means what? F dash x. That means f dash x less than 0. That means what happened? Finally what we get? When x approaches to C from left, before reaching C, f dash x sign is positive. And when it reach exactly at x equal to C, its value equal to 0. And when it crosses C and move towards right, then f dash x, what is the sign of f dash x? Sign of f dash x is what? Less than 0. That means what we conclude that when what happened, the value of fx reach maximum, at that time f dash x changes sign from what? Positive to negative. That means at x equal to C, we get the maximum value of fx is what? Fc. At that time f dash x changes sign from positive to negative. So we can conclude that using calculus, if f dash x changes sign from positive to negative when x crosses C from left to right. When x crosses the point C from left to right, at that time it changes sign from positive to what? Negative. So when f dash x changes sign from positive to negative, at that time positive to negative, when x crosses the point C, then this point C is called the point of maximum. And what is the maximum value? Maximum value is what? Fc. This is the basic idea about what to know about that maximum value exists at a point or not. Maximum value exists at that particular point if this condition is satisfied. Okay. And when you know that this particular point is a point of maxima, if you put the value of the point at the original function fx, you will get a functional value, and this functional value is called what? Maximum value of the function. Okay. This is the basic idea about using the calculus how to know a function have a maximum value at a particular point. This particular concept is called first order derivative test. So finally what we get? First order derivative test. What is the conclusion? If f dash x changes sign from positive to negative when x crosses the point C from left to right. Left to right. When x crosses the point C from left to right, at that moment f dash x changes sign from positive to negative. Then what is our conclusion? Then x is equal to C is called a point of maximum, and the maximum value is FC. Maximum value is what? FC. Okay. Now let us going to know about how to find the minimum value of a function using calculus. Let us draw again the graph. Suppose this is the graph of a function y equal to what? Fx. Suppose it is defined on an interval I. Suppose C is a point in the interval I. On this point, the value of the function is what? This is called Fc. Okay? And you see all the fx, these are the fx left of C. For every x left of C in the interval I, the fx is what? From the graph it is clear that fx is what? Greater than what? Fc. Greater than what? Fc. Similarly, in the right of C, whatever with the x, for every x what happen? Fx is what? Fx is what? Again greater than C. Greater than what? Fc. For all x belongs to what? I. If this condition is satisfied, then you can say that this Fc is the minimum value of Fx at x equal to what? C. Minimum value of Fx at x is equal to what? C. And what is C? And C is called the point of minima. C, the point C is called the point of minima. Now I am going to use the differential calculus here to know or to test that a function have a minimum value at a particular point. Okay, you see in this particular site there are points. In every point you can draw tangents, and tangents are like that, and tangents are making angle what? Tangents are making angle what? Obtuse. Therefore tan theta is what? Negative, and tan theta is nothing but what? F dash x. That means what happened? For every x at the left of C, what happened? You are getting what? F dash x less than 0. F dash x is what? Less than 0. Now at the right of C, there are many points. For every point there is for every x there is a y coordinate, and you will get a point on the curve. On the considering the point, you will draw the tangents. You will draw the tangent, and these tangents are making what? Angles acute, making acute angles with the positive direction of x-axis. Therefore tan theta is the slope of the tangent, and we know that slope of the tangent is denoted by, as per the calculus, this is f dash x, and tan theta is acute. Theta is acute, therefore tan theta is what? Positive, and therefore this side f dash x is what? Greater than 0. Okay, but at x equal to C, this is the FC. At x is equal to C, the tangent is what? Parallel to what? X-axis, and therefore you can say that this is what? F dash x equal to what? 0. F dash x is equal to what? 0. So finally we can conclude that, what are our conclusion? Here you see f dash x changes sign from negative to what? Positive. इस साइड में नेगेटिव था, उस साइड में पॉजिटिव है, एंड एक्स इज इक्वल टू सी में क्या है? 0 है. सो साइन कहाँ से कहाँ तक चेंज किया? नेगेटिव से पॉजिटिव तक क्या हो गया? चेंज हो गया. ओके, साइन चेंजेस फ्रॉम नेगेटिव टू पॉजिटिव when x crosses the point C from left to right. From what? Left to right. And then this particular point C is called point of minimum. Point of minimum. And what is the minimum value? Minimum value is this, and which is nothing but what? Value of the function at x equal to C, which is called FC. So what is our conclusion? Final conclusion is that if by first order derivative test, final conclusion is that if number 2, first one is maximum, for test for maximum, if f dash x changes sign from negative to positive when x crosses the point C from left to right. F dash changes sign from negative to positive when x crosses the point C from left to right, then the point C is called the point of minima, and the minimum value is FC. So remember that in a particular point the function have either a maximum value or minimum value. Together maximum and minimum value cannot occur in a particular point. So in this case it is a minimum value. In earlier case it was a maximum value. Okay, but value will be same. You have to find the point of maxima or point of minima, and after finding that you have to put the value of that particular x in the function. You will get minimum and maximum value. So your main agenda is to find the point where the function have a maximum or minimum value. So what is the condition? If f dash changes sign from positive to negative, अगर positive से negative तब जा रहा है, change हो रहा है तो maximum हो रहा है कोई भी point में, और negative से positive तक change हो रहा है तो उसका क्या नाम है? इसका नाम है point of minima, and the minimum value is what? That FC. Okay. And this particular point C, where the graph of the function is changed. Here you see the graph is in decreasing, and again it start to increase. So that particular point is name is called critical point. On that critical point you see from the maximum, if C is a critical point, where what happen? F dash x equal to what? 0. Critical point में क्या होता है? The derivative of function is what? 0 हो जाती है. Okay, derivative of function is what? 0. That means we can say that a function, a necessary condition for a function to have a maxima or minima, अगर maxima और minima मिलना चाहिए तो उसके लिए what is the condition? F dash x must be equal to 0 in some point of the domain. कोई भी domain की कोई भी point में क्या होगा? उसका क्या होना चाहिए? F dash x 0 होना चाहिए. Minimum, this is the necessary condition. It is not the sufficient one. It is just necessary condition. तो ये condition अगर होगा तो minima या maximum value मिल सकता है. Minimum value क्या होगा? मिल सकता है. Now I am going to draw a graph, very interesting graph. This is called y equal to fx equal to what? X cube. Fx equal to what? X cube. This graph is, if you plot the graph, you will see this graph is like that. The graph of the function is like that. Okay. Graph of the function is like that. Here x is equal to 0. If you find f dash x, you will get 3x square, and if you put f dash 0, this is the point 0. Okay. F dash 0 equal to what? 0. तो आपको f dash x equal to 0 at x equal to 0 क्या हो रहा है? मिल रहा है. You are getting f dash x equal to 0 at what? X equal to 0. Now if you draw the tangent, you tangent, every tangent are making what? Acute angle. That means tan theta is what? Positive. That means what? F dash x is what? Positive in the right of 0. If you consider this is the point, right of जितना डोमेन के अंदर जितना x है greater than 0 वाला है, all the x greater than 0, for every x your f dash x is what? Positive. Now taking points on this left of 0, that means when x less than 0, you will get some point. In every point we draw a tangent. This is the tangent, okay? This is the tangent, this is the tangent, okay? And this is the tangent, okay? Every tangents are again making angle what? Acute with the positive direction of what? X-axis. So here what happened? Tan theta is what? Positive, which is equal to what? F dash x. Okay. See, if you consider that x crosses the point 0 from left to right, in this side f dash x sign is positive, and here f dash x sign is remain positive. That means there is no change of f dash x. When it crosses the point, still f dash x equal to 0 at x equal to 0. 0 होने के बावजूद भी क्या हुआ? उधर भी पॉजिटिव रहा, उधर भी पॉजिटिव हुआ, साइन चेंज नहीं हुआ. जब साइन चेंज नहीं हुआ तो then we can say that the function fx has neither maximum nor minimum value at x equal to 0. मैंने कहा था आप लोगों को f dash x equal to 0 is the necessary condition, not sufficient condition. f dash x 0 होने से क्या हो सकता है? कोई भी पॉइंट में मैक्सिमा या मिनिमम वैल्यू मिल सकता है. इट इज़ नॉट द सफिशिएंट, मिलेगा, ज़रूर मिलेगा, ऐसा नहीं है. इट इज़ नॉट द सफिशिएंट कंडीशन दैट मैक्सिमम एंड मिनिमम वैल्यू मस्ट एग्जिस्ट. The condition says that if f dash x equal to 0 in a particular point, then at the point C, what happen? Maximum and minimum value may occur. But in this particular example, still f dash x equal to 0 at a particular point x equal to 0. But from the graphically we see that f dash x not changing its sign from positive to negative or negative to positive. So by the first derivative test, we can conclude that this 0 is not a point of maxima nor a point of minima. This type of point have a special name. This is a special name, and these are called the point x equal to 0 is called what? Neither maxima nor minima in this particular case. After still f dash x equal to 0, and this particular point is called point of inflection. It is called what? Point of inflection. It is called point of inflection. It is not the critical point. But if f dash x equal to 0 implies if you get some point, suppose C1, C2, C3 dot dot dot, okay? And where if you get either a maximum value or minimum value, then these points are called what? Critical point. And if among these point, if you get a point where neither maxima nor minima occurred, then that particular point is called point of inflection. Point of what? Inflection. Okay. So very important thing is that a function have a maxima or minima is the necessary condition is that f dash x equal to what? क्या होना चाहिए? 0 होना चाहिए. f dash x अगर 0 हो जाए तो मैक्सिमा और मिनिमा मिलने की उम्मीद रहती है, लेकिन मैक्सिमा और मिनिमा मिलेगा ये श्योर नहीं है. ठीक है. दिस इज द वन वेरी इंपॉर्टेंट कॉन्सेप्ट. ओके. सो व्हाट वी अंडरस्टैंड फाइनली फर्स्ट ऑर्डर डेरिवेटिव टेस्ट में if your that is f dash x changes sign from positive to negative in a particular point where x crosses that point from left to what? Right. And in such cases we can say that the function have a positive से negative होगा तो क्या होगा? Function have a maximum value at that point. Or if f dash x changes sign from negative to positive, then what happen? You can say that the function have a minimum value at that particular point. And if f dash x never changes sign never changes sign when x crosses the point from left to right. तो लेफ्ट टू राइट से x क्रॉस अगर साइन चेंज नहीं हुआ, पॉजिटिव से पॉजिटिव रह गया या नेगेटिव से नेगेटिव रह गया, इन सच केसेस व्हाट हैपन, यू कैन कंक्लूड दैट द फंक्शन हैव नाइदर मैक्सिमा नॉर मिनिमा एंड दैट पर्टिकुलर पॉइंट is called point of inflection. Otherwise, the other point where maxima and minimum point we are getting, these are called what? These are called what? Critical point, or sometimes it is called what? Stationary point. Sometimes it is called what? Stationary. Why stationary? Because if you see there is a called mountain. There are so many the way of mountain. You see, these are the stationary point. These are the stationary point, and these are the point called either maxima or minimum point. Okay, so if you draw the graph, this is the graph of the function. So these are the stationary point where you are getting either maxima or minimum value. Okay, that means what happen in a particular domain. Suppose this is the domain of a function. That means in a domain of a function, a particular function have more than one maximum value or more than one minimum value may occur. More than one maximum value or more than one minimum value occur. You never imagine, never say that maximum value means what? Greatest value, and minimum value means what? Least value. Not at all. In this particular graph, you see, if you say this is one maximum value we are getting, this is one maximum value, we are here, this is one minimum value. So among this minimum value, maximum value, which one is the largest? We cannot say. After finding it, we can say that this is the highest value. Okay, maximum value not mean that the greatest value, or minimum value not mean that it is the least value. There will be some conditions we will discuss further in the next coming classes. Okay, so remember that a function have more than one maximum value or more than one minimum value. Okay, in a particular domain, you can get, after getting f dash x equal to 0, you can get more number of points where f dash x is equal to 0. If you test this on that particular points, and you may get more than one maximum value or more than one minimum value. Okay, now I am going to discuss an important point: local maximum or local minimum. Local maxima or local minima. So this is the concept is same, definition is everything in there is local. For example, suppose if you consider India is the domain of a function, and comparing to India, if you consider suppose a town Guwahati, then Guwahati is a very small town compared to India. So if we restrict our domain into Guwahati, then in such cases, whatever be the maximum or minimum value we will get of a function, and that particular maximum minimum value are called local maxima or local minima. For very simply you say, for the Assam is sub whole domain, big domain, and for if you squeeze this domain into suppose Hujai town, then the Hujai town is a very small town compared to Assam, and in such cases, whatever the maximum value and minimum value you are getting for a function, that maximum value is called local maxima and local minima. Okay, so local maxima and local minima, the definition is exactly same. That means what happen, if x is equal to c is a point of local maxima, then what will happen, f dash x changes sign from positive to negative at that point. And if x equal to c is a point of local minima, then f dash x changes sign from negative to positive. Negative to what? Positive. And if f dash x changes sign from positive to negative, then c is called point of local maxima. And from negative to positive, c is a point of local minima. So definitions are, there is no change in the definitions. Earlier case we discussed about large domain, and now we are discussing about very small domain. For a particular small domain, what happened? What is the, suppose in graphically you see, that is your earlier domain is what I, now so this is C. Near suppose H is a very small quantity, very small, whatever you imagine, then this point is C plus H, and that point is C minus H. And in this open interval, if your graph is like that, now you have to find the local maximum in this interval, not in the whole interval. So in this, whenever you are going to find in this particular interval, if what happen, fx, fx is less than fc for all x belongs to c minus h, c plus h in this interval, then for a very small interval, if this condition is satisfied, then we can say that fc is the local maximum value of the function, local maximum, or fx is greater than fc for all x belongs to this interval. All x belongs to what? This interval. The interval is c minus h, c plus h. Okay, it is called neighborhood. This particular name is open interval name is called neighborhood. Why neighborhood? Because this point c plus h or c minus h is a very near to c, because h is a very small quantity, very near. So here I am showing you little in a large way, but it actually a very small interval, that's why its name is called, this particular interval is name is called neighborhood, NHBD, neighborhood of c. It is called what? Neighborhood means what? एकदम नज़दीक हैं, जैसे हमारे घर के बाजू वालों को हम नाइबर कहते हैं, that's way here in maths it is used as neighborhood. Okay, so finally what we get, this local maximum and local minimum are the same concept as maxima or minima, just the domain is skews to very small one, very small one, whatever you imagine, like this. Okay, so the definition will be same, positive to negative local maximum, negative to positive local minimum. Okay, so I hope you understand. In the next class I will discuss few problems related to this particular topic, and I am sure that you will enjoy this particular chapter. The very important, the first order derivative, first point, remember f dash x changes sign from what? Positive to negative in a particular point, and that point is called point of local maxima, or you can say maxima, whatever be. And similarly f dash x changes sign from negative to positive at x equal to c, then that point is called point of what? Minima. And what is the minimum value? Functional value at this particular point x equal to c. And if f dash x never changes sign from when x crosses the point from left to right, पॉजिटिव था बाद में पॉजिटिव रह गया, नेगेटिव था बाद में नेगेटिव रह गया, in such cases what happen, you can say the point is neither a maxima nor a minima, and this particular point is called point of inflection, and other points are called where you are getting maxima or local minima, whatever be, and these particular points are called what? Critical point, or it is called stationary point. Okay, so this is we discuss about first order derivative. In the next class I will discuss about second order derivative, which is more applicable in solving the problems. Okay, and you go through the text. Once you read the text, you will understand better whatever I have discussed, everything in your text. And very important thing is that those students read text, they are performer. So always read text, always understand the line, and also communicate with your teachers whatever you have a doubt. I believe that you will enjoy the maths class. Thank you very much. Thank you.